Nak cakap lah. Tidak. Nak start lah.
Okay. Hello there. A very good day to all participants. Welcome to the second session of Mathematical Discourse. My name is Tae Kim Hong, the moderator and the supporting facilitator for this session. On behalf of the Center Director, Dr. Shah Jahan bin Asanakuti, the Deputy Director of the Training Program Division, Dr. Wan Noor Azmin binti Muhammad Sabri, and staff of Senior Wrexham, we would like to welcome all of you to this discourse on promoting mathematical reasoning through reason-based learning. What, why, and how? This is the second session of the discourse. Today, we are going to talk on the how to apply a reason-based learning in a maths classroom. In case you missed the first session on 30th of April, where we discussed about the what and why of reason-based learning, you can still access to the recorded video in Wrexham YouTube channel. Don't forget to give us an evaluation using the feedback form to qualify yourself for a certificate of participation when you have completed session 2. We invite audience to raise questions during Q&A session. Otherwise, you can raise your question in the chat box and we will try to pick up to answer you. Ladies and gentlemen, let's welcome the facilitator, Mr. Gan Teck Hock.
Hello.
Mr. Gan will lead the discussion on how to use reason-based learning in the classroom. He is no stranger to people in the teacher education community, where he served for more than 30 years. He is passionate about promoting the importance of reasoning in learning mathematics. Most of us are in trying time coping with the movement control. Although you can't reach us physically in Senior Wrexham, we are pleased to hold this sharing session, meeting you on air. We hope this little effort is far-reaching to raise awareness among teachers to enhance your classroom practices in mathematics. Without further ado, I shall pass this session to Mr. Gan. Mr. Gan, the session is yours now.
Thank you, Ms. Day. Good afternoon, ladies and gentlemen. It's good to have everybody back here again. While we wait for the PowerPoint to be shared, play again. Okay, here comes the PowerPoint. Let's start the discourse. Okay, let's start the Sorry, we have a little bit of technical problem here. Let's start the discourse with an encounter with a mathematics professor. As you can read there, the child is in the lift and they wanted to go to the 6th floor, and the parents are instructing her to hit the 3rd floor button twice. Of course, the question for us here is, hitting the 3rd floor button twice will never get to the 6th floor. Why it is so? Let's think about that. What do you think the girl would do?
Well, this is an interesting case. However, I think this little girl will follow the parents' instruction instead of a stranger.
That's common, right?
Yeah.
I think the girl need to grow up and learn the meaning of number in order to make sense of her experience here. Yeah, number has two meanings. One refer to a quantity, which we call it the cardinal number. Another one refer to positions or order. So third floor, sixth floor are all ordinal number. The 3 and 6 only show positions. If you hit the button twice, you will not get to sixth floor because you simply cannot add two ordinal number. Two persons standing at third floor would not get them to sixth floor, as simple as that.
Yeah.
This actually, again, remind us of our argument last sessions, the importance of mathematical reasonings in order to bring about a deeper understanding of mathematics. Now, let's have a very quick review on what we have discussed last sessions. We mainly focus on what is reasoning and also why is reasoning important. On what is reasoning, we have focused on two very fundamental reasoning in mathematics, which is the deductive and the inductive reasoning. We have also share with you our notions of reason-based and also take for granted learning in mathematics. We have also discussed Richard Scamm's notions of relational and instrumental understanding in mathematics. And also we have argued for the importance of reason-based learning to bring about relational understanding in mathematics. Overall, we have argued for the importance of reasonings in mathematics in terms of bringing about deeper understanding in mathematics, and which will in turn bring about learning that is continuous, learning that is not just for today, but is also for the future of our students, which is, we call it the sustainable learning. Now let's start the discourse with an example of one of the favorite of school students, quick mathematics. Mathematics that is enable them to get the answer very easily and in a very fast pace. It's a simple case here. A decimal number multiplied by 10 and divide by 10. Many students learn from the teachers that when you want to multiply by 10, you simply move the decimal point. Multiply by 10, you move the decimal point to the right by one place. If it is division, then you move the decimal point to the left. Very easy and very quick. You can get the correct answer. However, today, I would like to invite everybody to stop for a while and then think about this. We have done this for many years, but does the decimal point really move?
It looks like the decimal had changed the positions. I think in order to understand it, probably we should refer it to the place value chart.
Place value, right? Because that will enable us to understand, to answer the next question. Okay, if indeed the decimal point move, then why does it move? So if it did not move, then what actually happened? So let's look at the mathematics that will enable us to answer this question. Now, if you look at the table that I show you, apparently, when we multiply a decimal number by 10, the value of every digits will change. Take, for instance, the digit 6. The original value in 53.6, the digit 6 is 6/10, which is 0.6. When we multiply it by 10, it becomes 6. So the values have changed to the ones place. Whereas the digit 3, the original value is 1, so it's 3. When 3 multiplied by 10, it becomes 30. So now its value is the tens. Similarly, for the digit 5, the original value is 50 multiplied by 10, then it becomes 100. So now since every digit has increased its value by 10 times, and therefore the positions of the digit will be different in the place value chart. It looks like, okay, it looks like the decimal point has moved to the right. In actual case, it is the digit which has moved to the left.
Yeah.
Right. Similarly, for divide is the opposite. Okay, division will make the values of every digit decrease by 10 times. Okay, so that is a case for divide by 10.
So we have been learning about moving the decimal point, right?
That is what we mean by take for granted learning.
Yeah.
I think a lot of students have taken for granted that when you multiply or you divide, the decimal point will move. But in actual case, if we understand the importance of reason-based mathematics, the reason is not the decimal point has moved, but it is actually the digits of the number has changed its values. Okay. So our argument that we want to put forward in this discourse is actually how we should push our students from take for granted learning to reason-based learning in mathematics. And for that, I think to make reasoning as a way of teaching mathematics, it is a very long journey. It cannot be a one-off actions by the teacher. The teacher have to do it continuously in a very long time. So for that, we feel that we would like to recommend 3 ways which we think are very friendly to the teacher, which will enable the teacher to goes along this promoting reasoning's path in a sustainable way. I will illustrate all these ways by giving you a lot of example from the classroom. Now let's look at the first way. The term proof sound very threatening or very scary for many students, but in actually to prove is actually to develop a mathematically logical argument. From the term mathematically logical argument, I think it shows us how important it is in our own life. Now, since proof is so important, but it looks like proving has been abandoned for many teachers in their classroom for a long time. Very often, we see students coming telling us what they learn in the mathematics classroom are formulas, and the teacher show them the formula, teach them how to use the formula, how to apply it in whatever question they need to answer. That is definitely not reason-based mathematics. But our question here is, why is proving being abandoned in the mathematics classroom?
Well, if I go through the syllabus, I don't find that in the syllabus at the lower level, especially. And for that, you don't find all these kind of questions in the examinations. And so as such, besides the reasoning, it's not an easy process to teach the students and involve a lot of time. So teachers just leave that out in the classroom.
Oh, that sounds very sensible, isn't it? But however, if we are talking about developing reasoning among our students, then we need to start thinking about how we could provide the opportunities for our students to develop proof. Okay, so with that, we would like to offer a handy guide for everybody, because as Ms. Tay has mentioned just now, many students, including the teacher, consider proving as a very difficult task. So the question now will be how to make it not so difficult for the student. And this handy guide will be our suggestion to all the teachers out there. I will illustrate all this guide by example in the following examples. Let's look at this example. A very common proving task for primary school student. Area of a triangle, half base times height. Okay, sound very scary to many primary school students, and probably nobody has ever asked them to prove this. But everybody can remember what is half times base times height. Now, I think the first thing the teacher need to do is consider what is the required knowledge to prove the area formula of triangle. In this case, the most important and related required knowledge will be the area of a rectangle, which is length times breadth. Okay, in this case, it's B times H. After that, this is something that many teachers never think about. In order to get students to prove this, we must first consider all the possible cases involved here. Talking about formulas for triangle, this is not the only case. There are two more cases here. And of all these cases, some are very closely related to the required knowledge, which is the area of the basetime of a rectangle. Some are further away. The one closer will be easier to reason out. The one further away will be more difficult to reason out. So our question now is, of these three cases, which case should we ask the student to prove first, and why?
Well, the teachers up there can think about it. Or for my case, I think I will do the case 2 first, because the right triangle is directly related to the size of the rectangle if we draw a diagonal from one point to another. Subsequently, I will try case 1 because I can apply the knowledge of case 2 onto the acute triangle where it has two right triangle. And from there, from the experience of case 1, I will go to case 3 to prove that it is the area of triangle by also using the knowledge gained from case 2. What do you think, Mr. Gap?
Oh, I think you have explained it very well, Ms. Tay. Obviously, case 2 is very closely related to the rectangle. And I think most students can see easily that case 2, the right triangle is half of the rectangle, and therefore it is half of the area of rectangle. However, the interesting part is, after the students have proved case 2 with a right triangle, area is half base times height, then the knowledge gained here can actually be applied in the proving of case 1, where you can see obviously two right angle there, right? So which means that will make the proving of case 1 easier now after they have experienced the proving of case 2. So similarly, so when they go to case 3, where the right angle triangle is actually not in the rectangle, not in the triangle itself, but it is outside the triangle, which make it a little bit more difficult compared to case 1.
Yeah.
Okay, so let's look at another case for secondary school. This is about proving the angle property of a circle. Okay, first of all, as the guide said, we have to consider what is the required knowledge here. Obviously, to prove that the central circle N is 2 times the inscribed circle M. First of all, the student must already know the property of an isosceles triangle. The two equal side and the two equal angle. Other than that, another required knowledge will be the all inscribed angle from the same minor arc will be equal. Okay, so next we have to consider all the possible cases. Again, there are 2 more cases. So this time, looking at the 3 cases.
Oh, it looks difficult.
All of them look difficult.
Yeah.
All of them look equally difficult, right?
Yeah.
But however, if we were to consider the questions of which case should we ask our student to prove first? Think about it. Case 1, case 2, or case 3? The audience, you may have your own answers. But how many of you can see that case 2 is actually very close to the required knowledge, because there is an isosceles triangle there, triangle AOM. I repeat, triangle AOM. OM is a radius of the circle. OA is also the radius of the circle, and that makes triangle AOM an isosceles triangle. And because of that, we see another angle M there because of the property of an isosceles triangle. And that will actually make us see that triangle AOM is 180 degree minus 2M. So now we are very close to proving N is 2 times of M. See, since MOB is a straight line, and therefore a straight line angle is 180 degree, therefore 180 degree minus angle AOM, which is 180 degree minus 2M, that will give us the answer 2M. Now, with this proven, okay, with case 2 proven, if we refer to the second required knowledge, we see that case 2 and case 3, both the inscribed circle are extended from the same minor arc AB. And therefore, all these angles must be the same. And when all these angles must be the same, they will be M. And if they are M, therefore N is always equal to 2M. With case 2 proven, case 1 can be proven. And using the experience in proving case 1, I think it will be easier for students to reason out that case 2 is also a case of angle N, the central circle, is 2 times the inscribed circle, the central angle N is 2 times the inscribed angle M. So briefly from these 2 examples, we can see how a handy guide can actually help us to make proving not so difficult for students, provided we analyze it and make sure the proof is connected to the required knowledge. Okay, and then decide which of the possible cases will be easiest and should be proven first by the student. With that, it actually brings us to the second way, asking the why question. Okay, so now I think the why question is very easy to ask, just ask. But however, the important consideration here should be when should the question be asked and how should the question be asked. With that, let us look at this issue here. Again, I think based on my experience in the Malaysian mathematics classroom, these questions why seems to be a forgotten questions in many classrooms. Everybody has to ask this question. Okay, and sometimes certain teacher might even don't allow the student to ask this question. But again, back to the issue of promoting reasoning among the student, opportunity needs to be provided for the students now. Whether we like it or not, teachers and students must start to ask the questions why in the teaching and learning of mathematics. The handy guide for you, there's just 4 very straight points. And I will illustrate this handy guide by a lot of examples from the classroom too. Let's look at the first example. Reasoning by considering the meaning of mathematics. A simple question, what is 3 plus 2? When student gave us the answer 5, and then we are very happy with it and we stop there. However, we must realize that this question is not reason-based learning. This question is questioning about what the students have learned. It actually tests whether the students have learned what they are supposed to learn or not. And very often, they only check student learning by looking at the facts or the procedure, which are mostly instrumental understanding here. To promote reasoning, questions should not stop after student gave us the answer to the what question. The next question that we should continue asking should be, why is 3 plus 2 equal to 5? We seldom hear teacher answering this. And many primary students will be staring at us if we ask them this question, right?
It's too easy to answer.
So what would be the answer? I don't know. Teacher, you never explained to me, so I don't know. Now, in order to answer this question, students have to have a very good understanding of the meaning of addition. Then only we can ask the next question. If they are able to explain the why, then we will ask them, how do you show me that 3 plus 2 is 5 and no any other number? Now, the many ways students can show this to us and explain it to us, whatever way it is, it has to show students understanding of the meaning of addition. For example, student can just use a card with 3 birds and a card with 2 birds and show us that plus mean put the birds together. So 3 birds here, 2 birds there, put them together, I get 5 birds. That is the reasoning that primary school students can show us when they learn this. So reasoning is not necessarily as complicated as a lot of us think about it.
Mr. Gan, I'm sorry, Mr. Gan. Can the student use their fingers?
Oh, definitely. Anyway. This is just an example. Anyway, the student may use a finger to show 3 fingers on my left hand, 2 fingers on my left hand. So altogether, I have 5 fingers. The students may use marbles. The student may use block. Anyway, But what is important is whatever way the student showing us, it reflects they understand the meaning of addition. And that is the reasoning that we expect the student at the primary level, possibly primary 1 students being able to do. Okay? And this reasoning is important because this is questioning for learning. If the student were not did not understand the meanings of addition very properly, very deeply, but I think going through discussion about the meaning, it will help them to learn much better about what addition is. And questioning for learning normally will give us this outcome. Reasoning is promoted among our students, and the learning is normally about the concept, and they don't just know how to add, but they also know why when you add 2 plus 3, you get 5 and not 6. That actually brings us to not necessarily the question of why and how stop here. It can continue anytime when there is the proper chance for us to put forward the question. Example, when the student first learn addition much later in their primary school year, when they learn multiplication, well, we can pose this question to them. Let them compare. Why adding give you 5? Multiply give you 6. What is the reason? Now, we are expecting that if the student think about this question, discuss with the friends, discuss with the teacher, finally, when they are able to answer this question, they will acquire very good relational understanding, because they don't just understand addition and multiplication separately, but they are also able to connect multiplication with addition. This is for primary level. Okay. Of course, another way student can show us the difference between 3 plus 2 and 2 and 3 times 2 is showing picture card 2. Another way to promote reasoning when we want to ask why. Quick mathematics. I think favorite of many teachers too. But now we are talking about if you use quick mathematics, we need to extend the quick mathematics. Let's take example. I have a quick mathematics here. How to multiply a 2-digit number with 11. The method is very simple. You spread out the 2-digit, and then you add up the 2-digit to give you 7. And what do you do with 7? Put the 7 at the center, and you get the answer. Those of you who have calculator with you, you can quickly check whether this answer is correct or wrong. Let's look at another example. What about 63? Following the same quick mathematics, 6 plus 3 give us 9. Spread the 11, 1, 1. Spread the 6, 3. Then we will get 6, 9, 3. You can quickly check whether the answer is correct, but I can tell you, if you trust me, I tell you these answers are definitely correct. Very good. If our student can master this quick mathematics, we are very happy about it. But if we talk about developing reasoning skill, okay, we should not stop here. We must go one step further. And what is that one step further? Very simple. Ask them, why does this method work? What is happening here? All right. Very quickly, if I show you this, I think you can see why does this work. Right. When a two-digit number is multiplied by 11, we notice that the two digit at the center to be added are actually the 10 digit and the 1 digit. And the 10 digit will be the 100 place, and the 1 digit will be in the 1 place. That's how it works. But this is not the end yet. Okay, although we push them one step further, we can also bring them higher by another question. This is another example. Okay, so we can bring them higher to another question. Will it work for all two-digit numbers? Let's look at some example. What about 28 times 11? Would it work? What about 84 times 11? Will it work?
Well, our audience can try this, but if I follow your method, Mr. Gan, then my answer will split the 2 and 8 and add the two digits 2 and 8, then I will get 2108. However, I find that the 1 is actually representing the 10, so it has to be regrouped with the 2, so it becomes 308. So I make some adjustment by doing regrouping. The same case is 84. So 8 and 4 at the end, and I put 1 and 2 in the middle again. You find that the 1 should not be there. The 1 is a 10, represent 10. So it should be regrouped onto the 8. So it becomes a 924. Yeah. And then I start trying out, and I find that I can go as far as 99 times 11. And I find that, oh, there is something interesting. If I allow the student to explore this way, actually they find something, a new idea for themselves by doing such kind of extension, you know. So they're actually doing reasoning by themselves and also expanding their knowledge for themselves when you give them the opportunity to do some explanation like that.
Oh,
What do you think?
yeah, you make a very good point by expect the student. This opportunity provide students a chance to expand their knowledge, isn't it? For simply following the quick methods we teach them, they actually can expand it to include all two-digit number. Okay, that is what we means by when we use reasoning as a way to teach mathematics, then learning will be sustainable, not just for now, but it's also for the future. So this is an example that we can use for the primary school mathematics. Let's look at another example for the secondary school mathematics. Okay, how this quick mathematics can be extended to promote reasoning. Now, many teachers, many students have different ways to remember how to expand these expressions. Okay, I personally like this because the graphics show a smiling face there. So, and this is called a smiling expression, and that will give us 4 terms: am plus bn plus bm plus an. So again, to bring the student one step further, we just have to ask why there are 4 times of expansion. Why not 2 times? Why not just A and M, B and N? Why is it 4 times? Again, I think many of you can explain this by using symbolic representation. In this symbolic representation, the expandations was done twice. First with m plus n as a term. So a times m plus n, and then b times m plus n. and then you further expand it. That is the reason why you get 4 times of expansion. However, many students may find it difficult to handle symbolic representation because it simply looks very abstract to them. Here, I would like to share another ways of reasoning by a different types of representations using graphic. This is an example of graphical representations that can answer the question why there are 4 times of expansion involving here. It uses the area models of multiplications. A times n is the area of rectangle with length A and breadth B. So A plus B times m plus n is the area of the rectangle where the length is A plus B and the breadth is m plus n. Now, this actually shows that graphical reasoning is a very good tool to help students to do reasoning. Let's look at another example of using graphic representation. Proving the sum of 2 even number is even and the sum of 2 odd number is also even, which we have discussed and shown in session 1. Okay, the symbolic representation which is abstract. Now, how to use graphical representation? Any even number, we can represent it by 2 blocks, and all even number will end up with pair, but odd number will end up with 1 block with no pair. Okay, so generally, so if we have 2 even number, adding them together will give everybody a pair, so no issue. It will be still even number. And what happens if even and odd, and odd and odd? Okay, odd and odd, the one with no pair will pair up with the other one with no pair. So end up everybody is happy and everybody got a pair. So we will get an even number. Okay, another way, misconception. I think in take for granted learning, students will show a lot of misconception and the misconception will show in their error. This is one example. When students look at this picture card of football, there are 3 cards. So they make a conclusion that 2/3 of the football is 3 football, which is wrong. Right? So why is this wrong? If this question is thrown to the student, somehow or other the student have to search for the answer. The answer will show them that the answer is wrong simply because for fraction, every card must have equal number of football. So that helps the student to identify the misconception. Another example of misconception, secondary school level. This is a little bit more complicated. It involves multiplications of 2 matrices. Okay, so when Y question is thrown to the student, then again the student have to search. Now, many students will explain by this. They thought, okay, this is not the normal multiplication number. This is metric multiplication. And when you want to multiply 2 matrices, you must follow the rules. And the rule is, you must multiply row by column. Row 1 by column 1 will give you 19. Row 1 by column 2 will give you 22. Row 2 by column 1 will give you 33. And row 2 by row 2 will give you 50. So that's the answer. Good. Okay. An acceptable is an acceptable answer to our why question. However, this is still instrumental learning. It is not relational yet. So in order to push the student to relational understanding, we have to ask another why question. Why must row 1 multiply by column 1? Why can't row 1 multiply by row 2 or whatever? So in order to answer the second why, the student have to go back to understand the meaning of matrix multiplication. They can explain by, for example, a daily case. Two persons, Ali and Ben, they were buying apples and orange. First table showed the number of apples and oranges bought by Ali and Ben. The second table showed the price of the apple and oranges in two different shops. Now, if row 1 multiplied by row 2, okay, that is 19. What does that mean? That means 1 apple multiplied by 5, 2 oranges multiplied by 7. Okay. So that will give the answer 19. So net 19 simply means that is the amount of money that Ali need to buy if he bought it from shop A. Similarly, okay, if Ali buy from shop B, then it will be row 1 multiplied by column 2. And he has to pay 22 or dollars or whatever nomination of money will be the amount that he has to pay buying from B. And the multiplication involved row 2 will be this. That will be Ben. How much Ben has to pay if he buy from shop A, and how much Ben has to pay if he buy from shop B. So this explanation again show and help the student to deepen their understanding on the meaning of matrix multiplication. Okay, to conclude on this method, I think to answer why is actually to justify one's reasoning. And in justifying the reasoning, students always need to not just explain but also defend their reasoning, because their friends will critique on their reasoning. And these are two specific questions that we can use to help us. One is these two questions help students to justify their answers, and the other two questions help students to reason and justify their method. Here come to our final ways of teaching, that is conjecture. Now, a little bit information about conjecture. A conjecture is not a blind guess. It is a guess, but it is not a blind guess. It is an informed guess that is based on certain observed evidence or observed example. And investigating conjecture involves more than just making. After making, it involves refining it and testing whether it is true or not. Finally, here are 3 questions that we can help to guide us through the process of investigating conjecture. Let's look at an example. A primary school, this is a secondary school example. Finding the sum of 3 consecutive numbers, 4, 5, 6, 5, 6, 7, 9, 10, 11. Now, if we observe this carefully, 4, 5, 6, 5, 6, 7, 9, 10, 11, and if we compare to 99, 100, 10, 999, and 1000 and 1001. Now, we notice that the number at the center, you see, the number at the center 1 less is 4. One more, 1 left, say 5. 1 left is 4. 1 more is 6. 99, 100, and 101. 100, 1 less is 99. 1 more is 110. So that seems to show us a pattern. And the pattern seems to indicate that the sum of 3 consecutive numbers is always equal to 3 times the middle number. Is this? So now we are testing the conjecture. 36 times 3. Do we get the sum? Yes. 250 times 3. Do we get the sum? Yes. You can check this out yourself. And if we, now from, then student can go on with many other examples. But when we throw this question to the student again, there can be so many examples and so many true examples cannot prove that this is true. So asking this is actually asking the students to prove that the conjecture is always right. Now this is an example how we can prove. This is a very formal proof using symbolic representation. If n is the middle number, the number on the left will be n minus 1. The number on the right will be n plus 1. And therefore, the sum of the 3 consecutive numbers, after we add up the term, we will get 3n. But again, this formal proof may be difficult for many students. What about proving it by graphic representation? The 3 bar can actually represent 3 consecutive numbers. And we can see that taking 1 from the other side will make 3 equal bar. And that definitely show easily 3 times the middle number is equal to the sum of the 3 consecutive number. Okay, so very quickly, these are a set of proposed steps for you to consider if you want to guide your student to do learning mathematics by conjecture, study specific example, identify the pattern or regularity, then make a conjecture based on the pattern. Then further, test the conjecture, and we notice that this process is actually iterating there. Sometimes they may even need to refine the pattern. And until they are very happy, they can go to the next step of proving the conjecture. You notice that the first part of this based a lot on inductive reasoning, and the final proving is basing a lot on deductive reasoning. And the proving there can either be done formally, like do it using algebra, or informally using drawing, graphic representation. Another very quick example, primary school student, for commutative property of multiplication, we can give them some example, let them find out what is 3 times 2 and what is 2 times 3. They will study and they will find that the answer will be the same. They make the conjecture, then they test and refine the conjecture. From simple facts, they can go to more complicated multiplication according to their own ability. And finally, how would they prove that? Primary school, again, informal proof like graphic representation will be good. Things like this, using a card to represent t times 2, overturn it, it becomes 2 times 3. So the answer is the same. Another example, 5 times 7, overturn it, it becomes 7 times 5, it's still the same answer. Okay, so with that, I just like to very quickly highlight a very important point about using reasoning as a way to teach mathematics. Now, to reason and to explain your reason to the teacher is very stressful to many students. And many of them really feel threatened when the teacher asks them to share their reasoning. And whether we aware or not, we are most of the time is a source of problem. We are the one that cause them the stress.
Oh dear.
Okay, so with that, I would like to offer a very practical tip. Don't start by asking the student to justify their reasoning to us, the teacher, but instead put them together. Let them work with the friends. Let them explain to each other and critique each other. And later, when they are more used to it, then only we ask them to explain the reasoning to us.
Mr. Gan, are you done with this?
Yeah.
I have a request. The teacher, one of our speakers said, do speaker mind to go back to the previous slide? Just one
Which one?
slide. I think one slide before that.
Oh, look. Macam mana nak balik? Okay, balik. Yeah.
Is it this one? Mr. Chong? Mr. Chong?
What's the issue?
You said we are going too fast.
Oh, sorry, we are rushing for time. So can I proceed?
Yeah, I think so.
Okay, so I think with that, I think it's come to the time to sum up. Is there?
Okay. Reasoning is the fundamental of developing mathematical thinking. As you know that we try to emphasize and developing mathematical thinking through teaching and learning in the classroom based on some principles such as problem solving, communication, reasoning, relationships, and also with the use of technology. And if you notice that from our discussion in session one and session two, we more or less cover this important principle for teaching and learning. So we hope that this can help the teachers and also throw some lights to the teacher about how it should be done. And besides that, reasoning is the fundamental in understanding mathematics effectively and making the understanding of mathematics meaningful. And reasoning actually can also expand our logical thinking. And also, I think it should also increase our capacity of critical thinking. And if we are able to do that, then we are able to understand mathematics in depth, isn't it? And with more meanings. With this, if we are given opportunity to the students, then they are able to learn things by themselves and also getting ready themselves for future learning. Another point is reasoning actually can change the paradigm of maths learning in the classroom, where the students are so used to do mathematics with procedure and with very definite steps. So if they are given the opportunity to reason, then they will realize that, oh, those are not the only ways to solve mathematics problem. And with that, I think the pupils will gain the confidence and also acquire the resilience to face challenges in the future for any problems. So, however, the effort to promote reasoning is actually not a simple effort. I think it requires the skills of the teachers and students, the determinations, and also the perseverance of both the parties. And we hope that this reasoning can be a way of teaching so that it can be a sustainable effort.
Yeah, I think Miss Tay, you have summed up very well. So talking about sustainable learning and teaching, we have actually shared with you three teachers-friendly way. Namely, we have to start giving opportunity for students to do proof. Then we have to make asking the why question as a routine practice in our classroom. And finally, we have to train our students to investigate mathematical contents by conjecture. So with that, Back to you, Miss Day.
Oh, thank you very much, Mr. Gan, for the sharing. And we would like to open these sessions to our listeners down there.
Stop share.
If you have any question, you can type them in the chat box, or otherwise you can just turn on your mic and then speak direct to us, and Mr. Gan will answer you. Yeah, any questions from all of you? Very quiet.
Mr. Gan, if I may,
Yes.
Mr. Gan, the
Yes.
way when we ask them to develop the proof, asking them why, I think in some sense, we promote critical thinking to them, isn't it?
Yeah, I totally agree with that. Yes, yes.
So,
Yes.
I'm teaching science, so I think critical thinking is the venue of science only. But I think mathematics you can have a critical thinking in mathematics too.
Yes, thank you, Mr. Safudin. So definitely, okay, critical thinking and creative thinking are also talks about in the learning of mathematics. Okay, but a more common terms that everybody in mathematics talk about is actually mathematical reasoning. But with mathematical reasoning, I think critical thinking, creative thinking will develop and also will be required.
Yeah, thank you, Safuddin. Any more questions? We can take another questions from all of you. All our audience is very happy with Mr. Gan's very systematic explanations. If not, then
Maybe Miss Day, you
Yeah.
can tell. Are they aware of the live? They can refer to the recording later.
Yes, they are aware of it. If you feel that you still have something missing, you can go to the Wrexham YouTube channel to look up for this again and read through it. And with that, I would like to invite everybody to turn on your video cam, and then we would like to take a picture as a record of your presence.
Oh, jump.
Is Chiam there?
Yeah.
Hi, Dr. Chiam. Nice to meet you.
Hi.
Hi, everybody. Whether you know me or not, I will still say hi.
Okay. 3, 2, 1. Click. One more time. Lisa. Next page. Okay. Next page. Turn on your video cam. Okay. 1, 2, 3. Right. Any more? Lisa? One more? We have many pages. A last page. Okay. One more. 3, 2, 1. Go. Okay. So we also need you to fill up the feedback form. Lisa, did you upload it? Yeah, please upload it to the chat box and fill up the form and then send it back to us so that when you have true attendance, we would like to issue a certificate of participations as an appreciation to your attendance. And then before, are you able to do that, Lisa? Yeah. So while waiting for Visa, I would like to say something. Before I close this session, just please remember to get access to the link for the evaluations. And I would like to say thank you once more to Mr. Gan for being the anchor of this program. the center director.
Thank you to you too, Miss Tay.
Okay, the center director and the deputy director who always provide us the moral support. The ICT team members who are also around on the standby mode to offer technical assistance, and other staff who provide the administrative role. Last but not least, thank you to each and everyone who participate in this discourse. I hope the learning today wrap up well with the previous discussions. And most importantly, you can bring this new learning and start to practice in your maths classes with your students. And all of you, I think all of you deserve a round of virtual applause. Shall we do it? Is there? Yeah. And if there is one here, yeah, you can do that, right? At the base of your,
Oh, can do
so
that.
yeah, just click and then,
Okay.
yeah, that's, you can do that.
Oh, yeah.
Yes. Okay, and we call it a day. Thank you very much, everybody. And we hope to see you again. We will see and we will find more gaps where we can help the teachers. We hope that this session
Definitely,
is useful,
yes.
and we will come on air again to have further discussions. Right?
So do give us feedback.
Yeah, give us feedback. Those are important for us to do some future planning. So stay safe and till we meet again. Bye-bye.
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 Hello, Michael. Is that Michael? Oh, it's off already. Hi,
He's still there.
is
I
that
think he can-
Michael?
He's talking to you, but I think he got to unmute his mic. Tell him to.
Please turn on your mic.
Hello, Cham.
Yes.
Question to ask
Hi,
you
Cham.
later.
Ah, okay.
Let
Is
Michael
that
talk first.
Michael, is that you?
Yes, please.
Yeah. Nice to meet you again.
Michael from where?
Michael is from Ghana.
Oh.
Michael Robson is one
Hello,
of,
Michael. Miss Tay
Yeah.
always
Hello.
talk about your class. So I know your class.
So what's he,
Thank you very much for the opportunity.
Yeah.
Yeah.
So nice to have you here.
And Michael, you can do some teaching with your teachers in Ghana.
Yes,
Borrow
of
these
course.
ideas, and then you can do that in Ghana.
Okay.
One session with him.
Yeah, or if not, you can get all your teachers from Ghana, and then we can have a sessions like that to help you.
Okay.
Yeah, you make the arrangement, and then we can help you with that online session.
I will try that. You give us the necessary
Okay.
assistance.
Today, I'm not sure whether Gertrude
Thank you
is
very
here.
much.
Yeah.
Yeah. For that one, I can't tell. I can't tell. But I saw her yesterday with the mathematical thinking lesson 13,
Oh, lesson
developing
30.
higher.
Yeah,
The other course.
that's right. I logged in
I,
yesterday, but
yeah.
I'm still very quiet.
Asami lesson.
This is our Deputy Director, Dr.
Yeah,
Wan
masuk,
Azmin.
Hi,
Yeah.
Michael. Nice to meet you. I mean, nice to meet you virtually.
That's why I said nice to have you rather than meet you.
How are you, Michael?
I'm doing well by God's grace. I hope you are also fine.
Yeah, I'm good. Nice to meet you guys.
All right.
virtually.
Yeah, I know Joseph have added new members to the family.
It's a lot while.
Yeah.
Okay.
So we hope to meet you again in some other platform, Michael. Bye-bye.
Bye.
Yeah, Dr. Chiam.
Day. This one, the other day I Mong Cha Cha, I missed the first lot.
Oh,
30th
okay.
April. This one I want to ask, now I'm more involved with STEM, science thing. Then somehow I don't know the maths, the inquiry-based maths education, it's not moving. So I don't know how this one in STEM, the way I see them doing things, it's like maths stand alone, not being put inside. So I don't know lah.
There is a concern now. There is a concern. Okay, Dr. Min is involved. She is our deputy director now.
Oh, okay. Hi.
Mr. T is from Kent.
No,
Yeah,
this
Mr. Teh, same
Mr. T is
IPG.
one of the IBME facilitator.
Oh, Mr. Teh.
Ah.
Oh,
That one
okay.
is that one is Mr. Teh.
Ah.
I'm more
okay.
with the science now.
Yeah, now with the
Oh,
science.
science.
Okay.
Science.
So the way I see them, I see the progress that is not much. The things that they are doing is more of maths alone, without involving the science and other things into the, So I don't know how should we get this thing move.
Integrating the mathematics together with the STEM.
But you are talking about the so-called inquiry-based learning in mathematics, right? This
Yes.
team, right? I think right from the beginning, this team is only thinking about mathematics. They are not thinking about STEM.
Yeah.
So they still wonder they are not integrating it with STEM.
How about that NPDL?
NPDL.
The pedagogy for deep learning, that one?
I
in that NPDL, you can.
I don't see that in maths.
Oh,
So
maybe
I
because
don't-
the topic. The topic. Can you please give us one example?
Like for science, I just finished writing one module on science, which is flying kites. So in flying kites, there are a lot of things in flying kites. The maths, the science will be like force and then locomotion, and all this aerofoil and all this lah. Then in maths, actually what I see is the distance and then speed and all this we can put in. Then in RBT, maybe reka bentuk and all this. Like even in maths also pengukuran and all this, ruas permukaan and all this. But I don't see any such activities from the maths people, from the maths project. So looks like now what I see is or I don't know, or maybe I'm more involved with science. The science is the more dominant one, but maths itself, they cannot come up with one, and then with science or other things to complement them.
Yeah, so far most of
One, maybe Cham, just a suggestion. One way that you may try out with your maths paper is this. You already have your science projects or whatever, right? For example, your flying kite.
Yeah.
So bring in the maths paper, ask them to sit down and study your project, like your kite, and then throw them the question, what mathematics are. Then in the process of implementing that project, so how this knowledge can be highlighted. So it looks like I think I can understand your maths people, because possibly they are just, I think the issue is like this, when the ministry talk about STEM, the teaching of STEM, so the inquiry-based learning in science is brought in as the methodology for STEM, teaching,
Yes.
But somehow later the maths try to come in, and so they created this thing called inquiry-based learning in mathematics. But they forgot that the purpose of IBSC in science is for STEM. So when they created this IBSC for mathematics, they forgot that they have to link it to STEM. So you possibly have to have discussions with them on things like that, I think.
Yeah, I think that
Ah.
discussion should be done with teachers on how to conduct the STEM learning. Then I think they will see that how to incorporate the maths, science, engineering, and the technology inside the STEM. Because sometimes if you don't discuss, we don't see actually.
Yeah.
Yeah?
Because in RegSem, I think our approach to STEM is not really like what they are doing, right?
Yeah,
Maybe
we are
Miss Tay can have a better explanation. I dare not explain in front of her. If she's not here, I will explain to you. But because the Sifu is here, so the kakia better keep quiet.
No.
So,
Yeah.
seriously, I think Rexham, we approach the teaching of STEM in a
Yeah,
very different.
we actually use the integrated approach.
Oh,
Yeah, we
okay.
use the integrated approach where the STEM we use the approaches in teaching science, teaching mathematics, right? So all these approaches are being applied when you have a STEM learning. And then, of course, coupled with the application of technology. And then we also use the engineering processes to find things.
Yeah.
Yeah, so as a result of that, you are not so worried whether I am learning too much of science, I'm learning too much of mathematics. At any time when you do a project, you integrate all
Yes.
things together for the
All the
application
disciplines.
side.
Yeah. It should be that way. That's what I see. So when I look at the maths thing, or maybe I'm not good enough lah. I feel like macam just tak kena somehow, just tak kena like that lah. Maybe I'm not knowledgeable enough lah. I can't see it.
So if you can look up the STEM integrates lah, the approach is also like that, but the four subjects should not be existing in isolations, but each subjects have contributed certain characteristics where you can incorporate it or integrate it together and which is related to the real life situations for applications. So this is what I learned.
Normally STEM kita memang relate to daily life.
Yeah.
Yes.
These applications.
Kalau you take any topic from the maths textbook, that one difficult.
Yeah.
You have to relate to daily life.
Okay.
Have you met before?
I'm not sure. I cannot really see your face. It's very small. I can't really see.
Dalam buat soalan.
What soalan?
Yes.
Soalan? Yeah.
Last year dekat PD.
No, not PD.
Are you still the IEE?
There's no more already. Dah bankrupt already. Now all everything online. No more PD. No more job.
Bankrupt.
Bankrupt.
Bankrupt, no money anymore.
I see. So things have changed.
Yeah. I used to be seeing, kena recycle how many times, so suddenly last year this COVID come, jobless already, no need missing.
So, okay,
Okay.
Dr. Kram, if there's anything, do contact us.
Okay.
Yeah. So thank you very much, whoever is still online. We have to sign off. And
Okay. See you.
hope
Thank
to
you
see
very much. Nice to
Bye-bye.
meet you.
Bye.
Bye.
Kenapa ini tak jadi tadi ya?